Okay, guys. Makebalo. Good afternoon. Hello, everybody. Today, we'll be doing the skewed and symmetrical data. And I want reminder: if you haven't subscribed, guys, please do so. It's very, very, very supporting to the boy. So let me start. Skewed and symmetric data, guys. I've explained one of the important things about skewed from my previous video. If you watched that video, guys, I'm just gonna put the link below. Please go and watch that video. Video is very, very important. Now, one of the important things here: symmetrical data. What is symmetrical? What is symmetrical? If something is symmetrical, I'm just gonna draw. I hope you have seen one of these mountain, if you call it a mountain, where I'm gonna make sure probably it's equal. I'm gonna try my best. This is one of these mountain where the left hand side is equals to the right hand side, but the right hand side is equals to the left hand side. This one here is the median. It's the median, which is also what? A mean. I hope you still remember what is a mean. Maths. Now, when the data is symmetrical, the data is equals to the what? To the median. This is the mean. But if your data is symmetrical, is equals to left hand side is equal to the right hand side. Symmetrical data means the mean is equals to what? To the median. Comparing it to the Bosque and the Whisker, I've touched Bosque and the Whisker in one of my previous videos. I'm gonna try to make sure to be equal. I'm gonna try my best. It's not into scale, guys, but just assume it's what? It's equal. I'm just going to try my best to be equal. Now, if from here going to here is equal from here going to here in length, if these two are equal in length, means that your mean is equals to what? Your median. If your data is symmetrical. Very, very, very important stuff there. Very, very important. Now, going to the positively skewed. I've touched this thing on one of my previous theorem about the purity. The skewed, positively skewed, or we call it, remember, we call it a skewed to the right. Is another way of calling it. If it's positively skewed or skewed to the right. Now, I'm just gonna draw one of these mountains now. If it's positively skewed, now the median here is not going to be equals to the mean. My median is just going to be somewhere here. The median has to make sure it separates my mountain here or my data equally. And then now my mean just going to be equals to, it's just going to be here. So now if the median and the mean, this is the mean. I hope you see my mountain is more skewed to this side, or it's more falling to this side. I hope you can see that different, that my mountain here is more or less falling to this side, to the positively side. And then now let me go to the Bosque and the whiskey. Let me try to draw on the Bosque and the whiskey. This is my Bosque and the whiskey where my data is positively skewed. So now this here is going to be my median. Right now my mean here is going to be somewhere here, because the mean has to separate my data equally. So it's going to be somewhere here, which is my mean. Now if you can see now, from here to the median, and then now from the median to my maximum here, this one here is shorter, this one here, it's what? It's longer. So this side now, it's what? It's positively skewed. So my data or my Bosque and the whiskey, it's skewed to what? To the right hand side. So here the mean is greater, the mean is greater than what? Than median. I hope you see, guys. I hope you understand. Very important stuff there. Now let's go to the negatively skewed. Okay guys, now let's go to the negatively skewed. Negatively skewed, or another way we usually call it, it's skewed to the left. If we are not saying negatively skewed, we are saying it's skewed to the left. It's skewed to this direction, going to this direction. Now let me try and draw my mountain. I'm not an artist, guys, so bear with me. Just gonna try like this. Just gonna try like this. And then from this one now, let me draw and try to find my median. Now from here, my median is going to be on this side. Now my mean, guys, my diagram is not into scale, so please bear with me. Just bear with me. I'm trying to explain this stuff. So here, this is my median, and this one here, it's what? It's my mean. So now I hope you see from this mountain. This mountain, it's falling to this direction. It's falling to this direction. So if it's falling to this direction, it's negatively skewed. Falling to it. Let me try and compare it now to what? To the Bosque and the whiskey diagram. Try and draw this box and whiskey. Use blue. this is my post and a whisker. Okay, this one is going to be my median. So if this one is my median, now let me draw my mean. My mean is going to be on this side, which is going to be my mean. And then now if you can compare now this side from the median, remember from the median coming to this side now, also from the median going to this side. I hope you can see from these colors which one is longer than the other. This one is shorter, and this one here, it's what? It's longer. From these two, you can see that my data is coming to this direction, meaning this one is longer. If this one is longer, now my data is what? It's negative. What? Skewed. It's negatively skewed or skewed to the left. Another thing that is very important now here, my mean is less than what? Than my median. If, guys, let me start afresh from there. Symmetrical, mean is equals to the median. Now it's positively skewed, my mean is greater than what? Than the median. And now if it's negatively skewed, my mean is less than what? Than a median. Very important, guys. Hope you understand. Thank you so much. Hey guys, if you have reached this far from this video, thank you so much guys for watching. Thank you so much for supporting. Here you'll be looking for a normal distribution. We'll be talking about normal distribution. Normal distribution has to do with your mean and what? And your standard deviation. I hope you still remember how you find a standard deviation. But now let me start by analyzing, guys, this if this mountain of mine here it's not equal, please bear with me. I try to draw it with my hand, so hopefully it's not into scale. So guys, please bear with me. I tried my best. I'm gonna try to probably separate this mountain of mine here equally. This, I hope it's separated equally, which is going to be my mean. So this is my mean. So now from here, if I go this side and also going to this side from my mean, this is a normal distribution. Separating it from this side and also now separating it from this side. Now it's going to be my mean plus standard deviation. I hope you still remember the standard deviation. Now also from this side, remember we're going to the positive side, that's why we add what? The standard deviation. And then from here it's my mean minus in what? My standard deviation. I hope you understand what is going on here. And then now trying to separating also this from here, trying to separate it from also from this here. Now this is going to be my standard deviation plus 2 standard deviation. And then now from this side is going to be my mean minus 2 standard deviation. So I hope you know there are questions where they are saying find 2 standard deviation or find from 1 standard deviation. You need to find the one from this side and also find the one from the other side. So this one here is from a 2 standard deviation, this one is from 1 standard deviation. This is my normal distribution. Now form from here to here, I'm just gonna say roughly 68%. And then now from here to here, just roughly, this is what 96%. Then going from far now, from where it stopped from my graph, that's where it's what, it's 100% of what, of my distribution. Now something very important, a reminder, the standard deviation. What is the standard deviation? What is the standard deviation? The standard deviation is a measure of the extent to which the data spread out. Sorry, data is spread. Is a measure, is measured the extent of which how the data spread each other out. That's why we draw this mountain. It's measuring, it's how our data is being spread. That's why it's very important to find the standard deviation, because that's where we measure of how the extent is our data spread out. I hope you still remember how to find the standard deviation using your calculator. There is a video that I did where how to find the standard deviation on your calculator. Very important stuff, guys. And another thing before I go, there's a thing we call what, variant. Very important, very important. How do you find a variant? A variant is a square of your standard deviation. It's a square of your standard deviation, meaning if you have your standard deviation, you just square the what, your variant. Meaning how, if you have a standard deviation, this is standard deviation, we are saying find a variant, you just square the what, your standard deviation. But now if they give you a variance, they say find a standard deviation, you just root until this root, you are left with what, with the standard deviation. Don't get confused there, guys. Thank you so much.